All right. Equation number 1. Which one of these 4 do you think is the best fit for equation number 1? Factoring? What do you guys think? For equation number 1, completing the square, factoring, graphing, or square root property.
For number 1, I put B.
You put B?
Yeah.
If you're going to factor, what do you have to have it equal to? 0.
So number 3 is B.
Number 3, I would put with B, yes.
I would say for number 1. All right, number 1 I think is C.
What'd you say, Michael? Square root property. This is what I would use as well. Here's why. Look at this piece over here. Those of you that were leaning towards factoring, I like that initial gut reaction. What multiplies to 9 but adds to -6?
3. Negative 3 times regular 3.
Negative 3 times
Negative 3. Wait.
another negative 3. So this guy over here would factor to be x minus 3 squared equals 16. And then we could do a square root of both sides. So square root property. If the left-hand side factors to be a perfect square, square root property is a good bet. Again, equal to 0 is a good opportunity for factoring. What about number 2? You would use that one with graphing?
No, number 2 is A. A.
I would go with A on this one. Completing the square is where you say, you take this piece right here, you cut it in half, and then you square it. That's completing the square. And if you do it to one side, you do it to the other side. I like completing the square when you have just A and B on the same side. And this is an even number because we're going to take it and cut it in half. So if it's an even number for B, completing the square is a good choice. Process of elimination leaves what for number 4? C, graphing. This looks just like our parent function, but everything has been shifted down 1 from the parent. This would be a very easy one to graph. All right. I came around and passed out a handout. Everybody should have a front and back handout. We're going to use this instead of your book today because, like many other times with this book, does your book do it wrong? No. Does it do it in the most complicated, confusing way I have ever seen in my entire life? Yes. So we're going to do the Ms. Bolt version. We're going to be working with systems, guys. I need heads up and I need you to pay attention. We're going to look first at a system of linear equations. What kind of a shape will this make when I graph it? What kind of a shape is it going to make when I graph it? What'd you say? A line. It's going to make a line when I graph it. What's the y-intercept? -5. What's the slope? Not 3x, but just 3. Yep. A lot of times we write our slope as a fraction, so this would be 3 over what? 3 over 1. So I'm going to go mark my y-intercept down here at -5. From there, I'm going to go up 3 and right 1, up 3 and right 1, up 3 and right 1 until I can't do that anymore. And then I'm going to go backwards. And then I'm going to grab my straight edge and connect those dots. The side of your student ID works really, really well for this. What kind of a shape does the other equation make? What kind of a shape does this second equation make? It's another line.
Wait, how can you tell which is the line?
Are there any exponents? Do you have x and y? It's a line. That's how you can tell. Good question. If it has both x and y, and there's no exponents, there's no radicals, there's nothing weird, just x and y and some numbers and some pluses and minuses, you've got a line. I'm going to put this in slope-intercept form so that we can graph it just like the one above it. So I'm going to subtract 4x from both sides. So I'd have negative 2y equals negative 4x plus 6. How do I get y all alone now? Divide everybody by negative 2. What is negative 4x divided by negative 2? Close.
Oh, 2x.
2x, because I have a negative divided by a negative. What about 6 divided by negative 2? Negative 3. So now that I have it in slope-intercept form, tell me what my y-intercept is. Negative 3. And what is my slope? 2, or 2 over 1, yes. So down here at negative 3, really close to the other line, but not exactly in the same spot. Up 2 and right 1, up 2 and right 1, until I can't do that anymore. And then I want to take this backwards as well. Grab my straight edge and connect those dots. Where is the solution? I'm sorry, how much? Not 1, 1, but very close. 1, 2 would be right here. 2, 1. Right here is where they cross each other. So 2, 1. What is occurring on the graph that makes this the solution? Yes. Intersect. The two lines intersect each other here. We're going to be working with systems today. Only the systems that we're going to be working with aren't two lines like this. We're going to work with a system that has one line and one parabola. I've got 3 examples of this just below this introductory problem. So I want to go look at those examples. Talk to me about this one right here. The functions intersect in how many points? 2 points. Right here and right here. So how many solutions does it have? 2 solutions. Those 2 solutions are about at what? If you had to ballpark the location of that ordered pair where they cross each other, you'd say it's about what? So this one over here is about where? It's not all the way over at -2. -1.5. I'm guessing here. -1.5. And what would the y part be? 2.1? Again, I'm just trying to approximate. I don't want to use whole numbers unless it looks like it's actually on the whole number. So about negative 1.5, 2.1. And what would the ordered pair be approximately for this other one? 3. And about, what, like 4.5? 4.5, 4.6, somewhere in there? Two separate places where they intersected each other. So we have two different x's and the y values that go with them. Look at the next one down. These intersect how many places? 1. So it has how many solutions? 1. Right here. That one looks nicer. What is the solution there? 4, negative 5. Look at the bottom one. What do you notice about this one that's different than the two above it? They don't touch. These graphs do not intersect anywhere, and they never will. So what would we say for the solution? No solution. So when we were solving systems of equations in the last unit, we can solve by graphing. That's what we've looked at right here. I want to get an overall conceptual understanding of what we're doing. We're trying to find where these two shapes are intersecting with each other on the graph. We can also use algebraic methods to solve these, because especially on a problem like this, did those cross at nice, pretty points? No. We had to make some estimations, some guesses. We can use algebraic techniques to solve these. Do you guys remember using the substitution method? That's the one we're going to focus on today. I'm going to take this right here, 6x plus 3. What is 6x plus 3 equal to? Y. So it's going to take the place of the y up here. So I'm going to have 6x plus 3 equals x squared plus 2x plus 7. I'm sorry, one more time? No, I liked your ideas. Keep going.
Do we add, since 6x and 2x are alike, can we just add those?
If they're on opposite sides of the equal sign, I can't put them together. But if I subtract it from over here, and I do the same thing to this side, then I can combine them. I like that idea. Let's go ahead and roll with that. We're going to subtract 6x from both sides. What am I trying to get this equal to if I'm subtracting 6x from both sides? I want this equal to what? 0. What else would I need to do here if I'm trying to get it equal to 0? Subtract the 3 from both sides. If I have this equal to 0, what's a good solving method? Factoring. Let's use factoring. All right. Do we have a GCF? No. How many terms do we have? 3 terms. When I'm talking about terms, I'm looking on just one side of the equal sign when I've got it equal to 0. How many pieces are there? No GCF, 3 terms, means I make my X in my box. Which piece goes here? X squared, our A term goes here. What goes here? 4, my C term. To figure out what goes in these 2 empty boxes, we're going to multiply A and C together. So 1 and 4. What's 1 times 4?
4.
4. What do I need this to add to? -4, my B value. What multiplies to +4 but adds to -4? -2 and -2. So -2x, -2x. Since these are the same, what are we going to see happen here? It's going to be the same thing. What are we going to get on either side? X minus 2, and on the other side, another x minus 2. Why is it -2 and not +2? Yep. Touching a negative, so I take the negative sign out. I have the same thing on both sides because these 2 were the same.
Can you do that x minus 2 squared thing or no?
Yep. So 0 equals x minus 2 squared. Where do I go from here? How do I get rid of the squared?
Square root.
Square root. How many answers do we normally get when we square root things?
2.
We normally get
2.
2, a positive and a negative, right? Is there such thing as a +0?
No.
-0?
No.
No. So this would just be 0 equals x minus 2. Because I don't have +0 and -0. 0 is my dividing line between positive and negative things. How do I solve that for x now? Add 2 to both sides. So that means x is 2. Am I done?
No.
Why not?
I mean, yes. No.
A little louder, Jaden. We have to find y. Remember, my solutions are ordered pairs. We're going to use our value for x to solve for y. Here's what I know so far about my solution. There's a 2 right here. I have no idea what goes in the y spot. How do I figure that out? How do I find out what's going to go in the y spot? We're going to take the 2, put it in the place of x. How many equations do I have to choose from? We had 2 at the beginning, right?
I'll do the y. I mean,
Does it matter which one we choose?
No.
You're going to get the same answer from either of these. Do you guys want to go with the top one or the bottom one?
Bottom.
Sounds like a plan. Why'd you choose bottom?
Just less things to worry about.
Less things to worry about, less operations. So y equals 6x plus 3. What are we putting in the place of the x? We're going to put a 2 in the place of the x. What's 6 times 2?
12.
So I have 12 plus 3. What is that? 15. That is the y part of my ordered pair. Excuse me. One solution. So on the other side of this paper, this system would look like which one? The top one, the middle one, or the bottom one? If you look on the front side, the one with parabolas and lines, does it look like the top one where it crosses in 2 spots, the middle one where it crossed in 1 spot, or the bottom where they didn't touch at all? How many answers did we find? We have one answer. It has an x part and a y part, but we only have one ordered pair. What would this look like if it was a problem like this? How would I know if I'm solving it this way that it crosses in 2 spots? I'm going to get 2 ordered pairs. I'm going to have 2 different values for x. How would I know if it's a no solution situation? when I do this part, I'd get imaginary roots. Imaginary things means they never touch. Let's try one that has two solutions. I'm going to look at these extra examples down at the bottom. What process can I use here? What was our first step up above? Substitution. Which one of these equations has a variable all by itself? Top one. Y equals all of this. So what do I do with all of that? Put it in the spot where y is. So this is going to be x squared plus 7x plus 5. That's what takes the place of the y. And then what else do I put? Minus 10x equals 5. What can I do from here? I can combine my like terms together. I've got a 7x minus 10x. What do I get when I put those together? 7x minus 10x. Negative 3x. Plus 5 equals 5. What should I do after that? Make it equal to 0. How do I make it equal to 0? Minus 5 on both sides. So it cancels here and gives me a 0, but it also cancels here. So I have x squared minus 3x equals 0. What do I look for next? Before I even do my box, what do I look for next? GCF. Be careful before you answer. Is there a greatest common factor? X. Both of these terms have an x. So I can take that out. If I take an x out of each piece, I would have x minus 3 left over. Is anything still squared? Then I don't need to make a box. How many factors do I have? Careful. How many factors? 2. What does the F in GCF stand for? Factor. It's the greatest common factor. So X is a factor. What do I do with my factors? Set them equal to 0. So I have x equals 0. That's one of my x's right there. I have x minus 3 equals 0. What do I do to find the other x? Add 3 to both sides. So x could also be 3. How many x's do we have? 2. So how many solutions are we going to have? 2. Do these two pieces together make an ordered pair? No. Here's what I know about my solutions so far. I know that one of them is 0 something, and the other one is 3 something. How do I find those somethings? Substitute back in. Because I have 2 different x's, how many times do I have to substitute in? Twice. Once for each x. All right. So for x equals 0, do you guys want to go with the top equation or the bottom equation? Top one? Okay. Does it matter? No. Y equals x squared. I'm going to write this actually in black. Y equals x squared plus 7x plus 5. What are we putting in everywhere we see an x? Zero. I put the same thing in for both of the x's. What's 0 squared? 0. What's 7 times 0? So I have 0 plus 0 plus 5. What is y? Y is 5. That goes here. Why does it go in this ordered pair and not the other one? Because the x was 0, so that 0 substituted in. Come on in, dear. There's my empty table. How do I find my other missing y? How do I find my other missing y? Same exact thing again. For x equals 3, I'm going to do exactly what we did with the other one. What am I putting in for x this time? 3. So 3 squared plus 7 times 3 plus 5.
Now, quick question.
Yes.
Never mind, I just figured it out.
Okay. What's 3 squared? 9. What's 7 times 3? 21. So 9 plus 21 plus 5. What is 9 plus 21 plus 5? 35. That's what I put in right here in the place of this y. How did we know again that it was going to have 2 solutions? We had 2 different x's. So it's going to have 2 solutions. Yes? We take each of our factors and we set them equal to 0. This is a factor. It was the greatest common factor. But we always take factors and set them equal to 0. So this got set equal to 0, and this got set equal to 0. Does that help? Yes. Okay. One last problem, and then we're going to call it a day. Talk to me about what I can do with this. We're going to substitute. Which one do I choose to substitute with? Y equals. So I take this right here. It's going to take the place of the y right here. What symbol was right in front of that y? A negative, a minus. Whenever I'm substituting in something with lots of pieces like this, if there's a minus in front of it, I have to use parentheses because I have to distribute that minus to all the pieces. So I'm going to have 4x minus x squared minus 8x plus 12 equals 8. What do I do from here? Distribute. I'm going to distribute that negative to each piece over here. Yep. So I have 4x minus x squared plus 8x minus 12 equals 8. What can I do now? 4x and 8x. Are they positive or negative or one of each? Both positive. Put them together. How many do you have? 12. So I have negative x squared plus 12x minus 12 equals 8. What do I do next?
Add 12 to 8.
Depends on what method you want to use. If you subtract 8 from both sides, then we can use factoring. If you add 12 to both sides, you could use the method of completing the square. I agree. Let's do some factoring. Negative x squared plus 12x minus 20 equals 0. Do you guys see this negative in front of the x squared? If I'm going to use factoring, I don't want that to be a negative. So I'm going to divide every piece by -1. If I do it to one part, as long as I do it to everything else, I'm allowed. including the 0 over here. Everybody gets divided by -1. So then I would have x squared minus 12x plus 20 equals 0. Do we have a GCF? No. How many terms do we have? 3 terms. If you have 3 terms and no GCF, we're doing X in a box. What do I put up here?
X squared.
X squared. What about down here? 20, my C value. I have to multiply the A and the C together, so I'm multiplying 1 and 20. 2 numbers that multiply to 20, what do I want them to add to?
-12.
-12. What multiplies to 20 but adds to -12?
-10 and
-10 and -2. Absolutely correct. So -10x, -2x. We're going to look at just 2 boxes at a time. What can I take out of just these top 2? What do they have in common? They have an x in common. What about -2 and 20? -2. Why are we taking a -2 and not a +2? Yep. It's touching a box that has a negative, so I take the negative out with it. All right, now we're going to go vertically. I'm not looking at this. I'm not looking at this. What do x squared and -2x have in common? X, so I can take that out. What about -10x and 20? -10. I can take a -10 out of each piece. So what are my 2 factors? X minus 10 and x minus 2. So I have x minus 10, x minus 2. That's my factored form. What do I do with each of those factors now? Set them each equal to 0. X minus 10 equals 0. X minus 2 equals 0. What do I do here? Add 10 to both sides. So x is 10. And the other one is, I'm sorry, how much? 2, because I would add 2 to both sides. How many solutions are we going to have? 2 solutions. What do I know about them so far? X is 10. I don't know the y. X is 2. I don't know the y. How do I find those y's? Substitute in. Do you guys want to go with the top equation or the bottom equation?
Let's go with the bottom. Top.
Quick show of hands. Who wants to use the top equation? Hands up. Who wants to use the bottom? Top wins. Does it matter?
Why would you want to use the bottom equation?
That's easier.
It's a y equals. Some people like the y equals ones. Does it matter which one you pick?
No.
You should get the same outcome either way. All right, so 4x minus y equals 8. What are we putting in the place of x? 10. Minus y equals 8. What's 4 times 10?
40.
40. So 40 minus y equals 8. How do I get y by itself? Minus 40 on both sides. What's 8 minus 40?
-32.
Negative 32. So I have negative y equals negative 32. How do I get y alone now? Divide it by a negative. So y equals what? Y equals 32. Which ordered pair do I put that in? The one with the 10. We substituted 10 in the place of x, so it goes in the one with the 10. So that goes here. We need to do the other one now. 4x minus y equals 8. What are we putting in the place of x this time? 2. So 4 times 2 minus y equals 8. What is 4 times 2? 8. So I have 8 minus y equals 8. To get y all alone, I need to?
Divide by negative.
Not yet.
Subtract 8.
Subtract 8 from both sides, and then I'll divide by a negative.
That's still gonna be 0.
Negative y equals 0. If I divide both sides by negative 1, is that going to change anything? Nope. Y is still 0. So that is going to go in as the y in the ordered pair where 2 was in the place of x. There's my solutions. That finishes Module 3 completely. Huh? We're done for today. Your homework, I'm going to give you until Tuesday to finish that up over what we just did. I'm going to pass out the reviews for the test so that on Monday and Tuesday in class we can review for your test. I won't see you guys. It depends. I won't see some people, I will see others. I think you guys will be in class on Wednesday, but I'm not planning anything. You guys will have just gotten done with 4 hours of PSAT testing. I am not going to conduct class like normal on Wednesday. You are welcome to review, you're welcome to ask me questions, but we're going to treat it like a brain break. Because after 4 hours of testing, the last thing you need is more of me or someone else talking to you.
For the PSAT?